Hello everyone. In this video we're going to be solving an interesting system of differential equations. As I said earlier, I'm going to try to bring you a different equation or a system of equations every week, hopefully getting gradually harder. So here we are. We have dx over dt equals x squared plus xy and dy over dt equals y squared plus xy. And we've done two equations already, so I'm going to try to include the links down below. You can also check out the playlist, differential equations. So x and y are both functions of t, right? Needless to say, I think. And we're given their derivatives. So let's go ahead and write this in a shorter way, since we're going to be using this notation. Let's go ahead and replace the x over dt with x prime. And by the way, x prime doesn't mean derivative of x with respect to x, because that would be 1, as you know, but it's just with respect to t. So x prime would be x squared plus xy, and y prime would be y squared plus xy. What do you notice about this system? First of all, they both have xy, right? And both of these equations are factorable. So let's go ahead and factor each one. This can be written as x times x plus y. And this one can be written as y times y plus x, but I'm going to write it as x plus y. Same thing, right? Great. Now, we're going to use a special substitution here, which is going to help us a lot. So this equation is unfortunately not separable, even if you turn it into something. Well, it is kind of separable, but we'll get to that later. Let's go ahead and do this first. I'm going to set x plus y equal to u, okay? And what does that imply? If u is equal to x plus y, since x and y are both functions of t, that means u is also a function of t, so we can differentiate both sides with respect to t, right? That would give us u prime equals x prime plus y prime. But since we already have equations for x prime and y prime, we can actually go ahead and add them. Let's use these versions. So x prime you can replace with x times x plus y, and y prime with y times x plus y. Notice that this is factorable. X plus y multiplied by x plus y, or you can just write it as x plus y to the second power. And that is equal to u prime, right? Great. But wait a minute, x plus y is u, right? So we can just replace this with u, and that gives us u prime equals u squared. This is awesome because this is an equation that can be solved easily, right? Hopefully you know that. Why? Because it's separable. So let's go ahead and write the u prime as du over dt equals u squared, and then separate the variables. Du over u squared is equal to dt. The next step would be integrating both sides with respect to whatever variables we have, right? The integral of 1 over u squared. Now think about it. You're integrating with respect to u. So it's kind of like the same as dx over x squared. The derivative of 1 over x is negative 1 over x squared. So this is going to be, the left-hand side is going to be negative 1 over u. The right-hand side is just going to be t plus a constant. Let's just say t plus c, right? You can use another constant to c1, c2, c3. And then we're going to go ahead and flip both sides. That's going to give us negative u equals 1 over t plus c. And then finally, by negating both sides, we get u equals negative 1 over t plus c. Obviously, there's more than one way to write it. You can kind of play with the constants, but I think this is what I prefer. So now we got u in terms of t, which is good. The next thing we're going to do is, before we take advantage of the fact that we know that u is equal to x plus y, but at this point, it's not going to help us unless we do the following. So remember, y prime was written as y times x plus y, and x prime was written as x times x plus y, right? So now let's go ahead and divide these. Why? Because they both contain x plus y. And it's going to simplify it. And guess what? It's going to make or give us a separable equation. X plus y is going to cancel out, and we're going to get a separable equation. In other words, it's going to look like this. Xy prime equals yx prime. Let's go ahead and replace y prime with dy over dx. I mean, that's not what I meant. I meant dy over dt, and this is going to be y times dx over dt. Of course, you can totally forget about dt's here and write this as x dy equals y dx. And then if you put the variables together, this is going to be dy over y equals dx over x. Beautiful, right? Now, if you integrate both sides, from here we're going to get the ln. Let's just forget about the absolute value. I mean, we could do that, but for the sake of simplicity, I want to write it as ln y equals ln x plus another constant. Let's just call that k. Now we're going to put these two together. Ln y minus ln x equals k. But ln y minus ln x is ln y over x. So I can just write it equal to k. And from here, by using definition, y over x can be written as e to the power k. But wait a minute, k is a constant. So e to the power k is also a constant. So let's go ahead and replace it with c1. Beautiful. From here, we get the following. Since y over x equals c sub 1, if you cross multiply, you get y equals c sub 1 multiplied by x, okay? So this equation gives us y in terms of x. Now, what are we going to do with this information, right? Well, if you go back and check what we use u for, u is x plus y. So now we can go ahead and use this actually. U equals x plus y. And what you can do is, since we're trying to solve for x and y separately in terms of t, you can actually replace y with this, y, because this gives you y in terms of x, which is very helpful in a scenario like this. So you can go ahead and replace y with c1x. And what that gives you is, if you take out the x, you're going to get 1 plus c1. Obviously, that's just another constant, right? If you want to call that c2, you can basically call that c2x. But you got to remember that c1 and c2 are related. Or you can totally leave it like this. That's perfectly fine. Now, the next thing we're going to do is also super important. Yes, u is equal to this in terms of x only. But at the same time, u is equal to something else. What is it? Remember, we found u in terms of t, right? So u is also equal to negative 1 over t plus c. So let's go ahead and put those two together. U equals x times 1 plus c1. Also, it's equal to negative 1 over t plus c. So what do you do with that type of information, right? Well, you can go ahead and actually divide both sides by 1 plus c1. That way you can get the x in terms of t completely. So now x can be written as negative 1 over t plus c multiplied by 1 plus c1. C and c1 are all coefficients, constants, so it doesn't really matter if you wanted to kind of change them a little bit, okay? So here's what we're going to do. Actually, I want to do this because that's going to make my work a little easier. So let's go ahead and write this first. It doesn't matter because they're multiplied. So we can now write x this way. But notice that this is just another constant, right? Isn't it? C1 is a constant, 1 plus C1 is a constant, the whole thing is a constant. Let's go ahead and replace it with C2 so that we can write x from here as C2 divided by T plus C. Again, C is a constant, right? So this gave us pretty much a simple form for x. Now, how do you find y from here? Easy, because we know that y is equal to C1 times x, y equals C1 times x. Therefore, from here, y can be written as C1 C2 divided by T plus C. And now we got the value of x and y at the same time in terms of t. Now, one thing you can do is plug these into the original equation and make sure that it checks our system. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and bye-bye.